Hi, my name is Suraj and my friend Kevin. We both are going to walk you through this presentation. Our project is real-time object classification using deep learning. In this presentation, we are going to give a description of implementation of our project, and we are also going to describe how our project is different to the references that we have used and have we exactly implemented which are given in the references, or did we do any enhancements. All these will be discussed in this presentation. Introduction. Our goal with this project is to implement a model that classifies with almost perfect accuracy and very low latency on dog breed classification when given a camera input, and this is going to be a real-time dog breed classification. So far, we have been able to build a model that classifies breeds with a more or less acceptable accuracy and latency. Please note that our model is as good as its training data. For the purpose of the project, we used COCO dataset combined with the Stanford dogs dataset for training the model, and in total, a little more than 20 breeds are supported. However, there is still room for improvement, and the final version is expected to produce far better performances. Tools we have used: Android Studio 3.5 for developing our application, that's going to be our kind of IDE, and Firebase to train our model, to make a training model, Google Android camera permissions obviously for the application, Material UI design toolkit for application, TensorFlow 2.0 is used to train the model. Moving to the functionality check. The current version of our application is going to have a launch screen or main menu, and it is going to classify the dog breed at real time with accuracy of the model just next to the dog breed. And we are thinking to add birds or cat species classification onto our application with a toggle switch, where our application would be able to not only classify the dog breeds but also the birds or cats species. And planning to add autofocus image stabilizer too. Moving on to the research papers. These are the research paper references that we more or less used to work on our project, and these were helpful while working on our application. Even though we haven't completely relied on the implementation given in the research paper references, we still have used it to some extent. And now my friend Kevin is going to take over and going to explain how our application is different to the research paper references and what extra have we added to our application.
Thank you, Suraj, for this great introduction. Hi everybody, I'm Kevin and I'm going to take over the presentation. So on the screen we have two tables. On the left hand side in red we have our references, and on the right hand side in green we have our project. So let's try to compare our references, the implementation and their features versus our project and our features that we have. So first of all, our references are using pre-processed non-real-time classification, meaning going from input, processing, and then output takes a relatively long amount of time, so which makes it non-real-time. Our references are mostly desktop-based application, meaning they're running on Windows OS and they're not optimized for mobile apps. Our references also use static image input, meaning they're using image files, JPEG, PNG, or whatever image format as an input source to their neural network or whichever model they use to implement their classification system. Our references also use convolutional neural networks, which we're also using, by the way, with TensorFlow and Keras to classify our input. Our references work with single classification, so basically meaning they're processing on a case-by-case basis. So one input, processing, and output, and then to classify another input file you have to restart over, so it's sequential and not continuous. Whereas a project uses real-time classification, it's built on mobile application, which is beneficial since the embedded camera on the mobile device is our input source. Dynamic video input is used for collecting our inputs, and we're trying to build a model for dual classification, meaning we'll be able to switch from dog breed classification to cat or bird species classification just by the press of a button. Let's move to the next slide. So here let's show a short demo of our application. Welcome to our apps demo. So without further ado, let's start our application. Let's click on the apps icon. We can see the splash screen, the welcome screen showing up with the app's name. So right now we have the main user interface, and let's scan our first breed, which is a Chihuahua. And we get the correct answer. This dog is in fact a Chihuahua. So let's move to the next one. We're currently looking at a Beagle, and we currently have Golden Retriever. Yes, we have Beagle. So our apps was also able to find this one. So let's move to the third test, which is a Golden Retriever. And yes, this is a Golden Retriever. Our application is correct. This dog is an American Bulldog, and our application is classifying it as a Staffordshire Terrier. Sorry for the pronunciation. Here we go, we have Bulldog, which is correct, but our application is kind of hesitating between Bulldog and Staffordshire Terrier. Therefore, we'll give it a wrong answer. So let's move to the next one. This is an Alaskan Malamute, and our application has it as a Australian Shepherd, which is not correct. American Eskimo, that's not correct. Alaskan Malamute, here we go. This is the correct classification. Tibetan Mastiff, yes, Alaskan Malamute. So we have the correct answer for this one. So we're now looking at a Doberman, and our application has it as an American Staffordshire, a German Pinscher. Okay, it seems we don't have the good answer for this one, so that's a failed test. So we currently have in total 2 failed test cases. Let's move to the next breed. This is a German Shepherd. So let's see if our application is able to find it. It's not an Australian Cattle Dog. Let's see if we're able to get more results by getting closer. It seems our application is not able to properly classify it. Let's give it a bit more time. Oh, here we go. We had German Shepherd, but we're going to classify it as a failed test case. So this dog right here is a pug. So it's not a Mastiff. You can notice that our application is still very versatile. It gets the correct answer, but sometimes still finds a way to switch from a correct answer to a wrong answer. So the pug was also a failed test case. So this is a Rottweiler. Let's try to see if our application recognizes the dog. So this is not a flat coated retriever, it's a Rottweiler. It's not a Tibetan Mastiff. It's not also a Labrador Retriever. Okay, so this is a Siberian Husky. Let's see if we're able to find it. Siberian Huskies are kind of similar to Malamutes. Malamutes are a bit bigger than Huskies, but this is also a failed test case. It's not a Siberian Husky. It's not a Malamute. I'm sorry. It's not an Akita. It's a Siberian Husky. So in total, our app performed sometimes well, sometimes not so well. So that was the end of our demo. Thank you for watching. So now back to the presentation. The remaining functionalities to build. So as discussed earlier, our goal would be to switch to a dual classification model by training our existing model to also classify either cat breeds or bird species. So right now we're looking at two data sets to help us achieve these goals. So the first one is the Caltech UCSD Birds 200 dataset that has 200 classes of birds inside, and the second one is the Kaggle cat breed dataset, which has 67 classes, meaning 67 cat breeds. So we're still discussing which one will be more advantageous, knowing we have more data for birds, but also knowing that cats are more frequent and easier to catch and classify in real life. Most of us have cats or dog pets, but not everybody has a bird pet. Let's move to the next slide. So now our project timeline. So our next step would be on April 1st to optimize our base feature, which is dog breed classification. So this optimization process will basically be trying to fine-tune our model's accuracy and trying to get as much correct classifications as possible with a higher accuracy. Since in the live demo you saw that our model isn't always 100% correct, we'll try to make it as reliable as possible. So our next step after that would be on April 10th, extra feature addition. So by then we'll have either the cat or the bird's parallel classification model added to our current feature. And the third step will be app debugging and A/B testing by April 15th. So that will be basically code cleaning and making sure our code is well commented. We're not using deprecated libraries, and our code is following the object-oriented programming guidelines with reusable classes and objects. So the final submission date is on April 25th. So we will have to submit the codes, the app documentation, and a user guide. So we will make sure our app documentation is well written with as much details as possible on our app implementation, the Android version we use, and all the libraries, special libraries, or various tools we use in implementing our application. The final report will be on May 2nd. So there we will upload a detailed app documentation from top to bottom, how to implement our application, going from an empty Android project with only the main activity to a full working dual classification model for birds and or cats and dogs. And we also upload screenshot, a demo video, and an implementation tutorial, also an APK file for quick checking, which will allow the teaching assistant or the professor to quickly run the application on any Android devices and check in real time and in live our application's accuracy and usefulness. So that was it for us. Thank you for staying tuned to the end of the video. Myself, Kevin Yanogo, and my teammate Suraj, we thank you for watching this video to the end, and we hope you will like our final product, which will be a dual classification mobile application for dogs and hopefully cats or birds. Thank you so much for staying tuned in, and thank you.